So the agenda for today is we'll introduce what Mule ESB is and what is the architecture that it is following, some of the core concepts and the basics. We'll see what Mule Flow does and what are the other core concepts that make Mule work. Okay, so what is a Mule ESB? It's nothing but it's a lightweight Java-based enterprise service bus. So the Mule itself is developed purely in Java, and it acts other than enterprise service bus. It is basically known as enterprise service bus, but it is more generically an integration platform. It provides more features than just behaving as a message servicing bus. It can be used in various manner. Other than using its ESB features, we can also use that as a standalone application for maintaining services, only to host the services, and we can also have it as a service backend for some web application purpose, even though if it's a single application as of now. And as the application grows, it can bring its integration features and all the messaging services that it has to integrate multiple applications into it. But the core features are its ESBs and ESB feature, but otherwise it's more of a platform wherein you can use it for a variety of different purposes. Like within your enterprise, you can use it only for your service creation and hosting, and multiple other applications within your enterprise can use that. Instead of having a separate service host provider or a service provider, we can use Mule ESB as one, because it has got Apache CXF embedded into it to host web services. So basically, we look at Mule as an integration platform which allows application integration possible. All the features of a normal ESB is built into Mule. The thing that is advantageous to Mule is that most of the activities that goes in creating an integration application, apart from the business logic, whatever we need to write to make the integration possible, just in case of, just like in JDBC, the way we set up the connections, all the interfaces that it requires and all that. So in a similar manner for integrating applications with various when we say integrating applications, it deals with applications of various formats and various protocols. So all that thing Mule takes care of very easily. It has got so many connectors that are available, which handles most of the protocols and the data formats for us. It does the transformation for us. So everything has been provided as a drag and drop. So most of the spaghetti code that we need to write, it's all written by the Mule ESB's implementation itself. So we just need to reuse them and then just build our application. So all the plumbing work that an integration platform that we require to do for integrating applications is all done by Mule ESB already. We just need to use its features to connect applications. It just gives us plug and play features, so we would be able to use them and just configure and use it. Mostly it's just configuration, and the only code that we write will be of our application logic. Otherwise all the other things Mule takes care of. And it's open source, and it's based on all the open standards. So basically it acts as a service bus. It lies in the center of your enterprise applications. It acts as the bus which carries the data from one application to other application, and in turn it handles all the transformation logic, the routing logic, security, transaction management. It provides all those services for all the applications that are integrating into it. So the name Mule, from its author, why the name Mule has come is that Mule means it's donkey. Basically, since donkey is used for carrying heavy load, similarly Mule is also basically used for carrying our data. That data is the load that they're talking about. So instead of naming it donkey, they have named it Mule. So from the name, the name itself more stresses on the fact that this particular ESB acts as the carrier of data, and that's its first and foremost purpose. and some of the capabilities that Mule has a service creation and hosting, which I touched upon. So since it has got Apache CXF embedded into it, that's the framework engine, the web service engine that it uses to create and host services, web services. It is able to host both SOAP web services and RESTful web services. From whatever I have seen in the last few years, that mostly we go for the RESTful web services due to its more SOAP is more verbose and somewhat difficult than the RESTful web services. RESTful web services makes use of the HTTP protocol itself, and if needed, we can go for the XML way of exchanging the data. Otherwise, we can go for more lightweight JSON format of data. But it supports everything, service creation and hosting, so that if there are other middleware applications that are there in our enterprise suite of products, just like a BPM, then if a BPM is there and for a particular task within the process, if it requires a service that needs to be invoked, then that service can be hosted in Mule ESB and they can be integrated with each other. So this way we can do. So it helps in other middleware applications being integrated as well, other products which are there for solving other problem domains. And service mediation is more for the location transparency, those concepts. So it is a highly distributable environment, and it provides a service mediation through the service interfaces that it exposes. So behind the service interface, what technology, what data, what protocol, it doesn't, the consuming application doesn't care about it. So it achieves the service mediation through decoupling its consuming applications from the providing applications, the service providing applications. And message routing is more of a concept wherein if the particular message is coming and depending upon some property or depending upon some logic, if we need to route the messages, across various destinations, if there are more than one destination available, going forward we will be looking at an example wherein if it's an insurance third party, like say third party intermediary, some company which is the intermediary company, and if the insurance all the insurance claims flows through that company, and depending on the claim that we receive, that company is going to route it to different actual insurance company which is going to reimburse the claim. So in that case, it has got more than one routing options that it need to do, meaning it has got more than one destination where the incoming message should go. So in these sort of scenarios, Mule comes up with its own components which enables us to easily configure these destination points, and based on the data that flows, meaning the data, the message that flows through the Mule ESB, we are able to derive that content or the logic from the content itself, and Mule takes care of just routing it to according to the destination as per the logic that we have configured. We will look at it in an example today. And we also have this data transformation, which is the key for any ESB or any integration platform, wherein when there are disparate applications using different data formats which coming together, so definitely a data transformation is required, and Mule ESB comes up with lot of out-of-the-box data transformers, which just by plugging in that our job is done. If we got to convert a byte array to a string or a string to byte array or various different kinds of these things, now we can just plug and play, and it's there out of the box. You just drag and drop, and then done. Your data transformation is done. But if you want to go for higher, more specific business logic data transformers, then it provides us components, transformers, wherein we can write actual Java code to get our transformations done. So it allows for more, it has this extensibility feature, since it follows everything is being all these are reusable components, whichever we are talking about, the routers, where the services are hosted, the data transformers, all these are reusable pieces and extensible pieces as well. And all these expose as an expose as a similar kind of an interface. Going forward, we'll look at what similar kind of an interface means. But basically, all these components are extensible, and if needed, we can directly write our code and then change the behavior of these components. So this is on a high level what a Mule ESB does. It's basically ESB and an integration platform, and it's purely Java based, and it follows all the SOA standards as well. And coming to the architecture that Mule follows, it's before going into what architecture Mule follows, let's see some of the challenges, the point-to-point integration, whatever it brought, and then we had this hub and spoke model, wherein we had a lot of spokes connected to the central hub, where all the processing logic was hosted there. And to solve all these problems, the thing that we need is when we are integrating applications and when we are doing service orchestration, so we are doing a specific set of tasks in a sequential manner. And to do that, so what they have done is they have broken down these series of tasks into their reusable components, into their standalone components, which can be used, which can be interchanged and used, which can be plugged and made a chain out of it. So that's this pipes and filters architecture style. It's an architecture pattern. What it says is that it is going to have different components, one after the other, connected through the pipes. The arrow marks are the pipes, and the actual the boxes, the message filters, all these are the filters. So each one is going to do some activity or the other, and these are the ones which are going to process the message that comes in to the application. So message flows into the application, and one after the other, each one are chained together, and the outgoing message is the one which is processed and which will be consumed by the destination application. So, so message filters can be of various kinds. It can be a transformer, it can be a router, it can be a component which performs some business logic, specific business logic to that particular domain. It can be anything. So this architecture provides us a flexibility of just taking this message filter out and putting it. The sequence can be interchanged, and at any point in time, if there is a change coming and we want to introduce some new component in between the flow, then it allows very smooth integration of that particular component without affecting all the others. And so this way, this architecture best fits for our service orchestration, and this is the architecture that forms the core of Mule. And so as you see, filter is a meaningful processing unit with a single entry point. What the single entry point means is that all these message filters, even though they are going to perform various different activities like routing, transforming, or some business logic execution, everybody is going to have a single interface, Java interface. So all these components are going to have the same interface, and there will be a particular method that is exposed, and the one that implements this particular interface is going to be the specific ones. But otherwise, on a high level, for a message perspective, it is all going to be the same. That's why we would be able to plug anywhere at any location any component, and when there is a change, only the implementation detail is going to change. Still, the interface is going to remain the same. So using this architecture, we would be able to decouple and then hide the implementation details out into whatever component that implements this interface. So this way, this architecture forms the base of Mule. We'll see how this architecture is implemented and what's the name of that architecture. We'll see all of that. And when we go when we say what filter is actually about, it's a single processing, it's a processing unit, and it's a standalone processing unit. It does not depend on any other thing. That receives a message and then processes the message and then delivers the message. So each message filter in the chain that is configured, everything receives a particular message, does some logics, does some manipulation on the message, and then it gives the output message to the next filter, which acts as the input for this particular filter. Pipe is just a connection between these two, and it holds the whole thing together. That's the pipe. So yeah, this architecture is best suited for handling changes and modifications if your integrating applications are constantly changing and there are introduction of various other applications to be integrated within the service that you're orchestrating or within the enterprise domain that you're working with. If there are lots of changes, then this architecture best fits, because the integration is easy, because it's all going to be hidden behind a particular interface, which is going to remain same for the whole chain in the service orchestration. And yeah, since it has got the same interface, it's going to be plugged at any point in any location. The integration is going to be seamless. So when we look at how Mule implements this particular architecture, Mule has come up with a concept called flows. So the name flow comes from the fact that the message that comes into the application flows through the whole set of the message through the application flows through Mule. So that message can be controlled. The way the message flows can be controlled using all the message processes that Mule provides us. So hence the name flow. Basically, Mule provides us the capability to control the way a particular message flows through its ESB and then deliver to one target application. So since we are able to have a more control over what message, the way the message flows through the application, the architecture that it follows is named as flow, and it is represented in XML in the configuration as a flow element, as a flow element. So this also this is the same pipe and filter architecture, wherein the pipes are the chains and the connectors that connects together, and everything is going to be this pipe is implemented by the fact that everything is going to reside inside a flow element. So the way we write our components inside the flow element, that forms our pipe. The sequential order that we write inside the flow XML element, that forms the pipe, and the actual message processes we would be writing transformers, routers. There are specific elements that denotes these things. And other than that, the important point to note is that there is a message source. Message source is completely different from message processor in the fact that message source does not do any particular manipulation on the logic. So message source is the place where the data gets generated, where the message gets generated, and it acts as the source, and the first thing that listens to the message source is one of the message processor. It could be an expression filter. So we have this message source and message processors interconnected, and each message processor can take a role of either transformer, routers, filters, or components. So all the Mule, when we say this flows, and these flows are implemented using this message processor and message source concept, to get this flow created in Mule, we have got the Mule Studio, which the IDE that they have provided, wherein we would be able to drag and drop contents onto the IDE, and we would be able to create the flow in a more UI in a visual manner, and the actual XML will be written by the IDE itself, and the XML will be formed. If the application is getting more and more complex, then we would be some people may feel that the visual way of developing that flow is easy, but I somehow feel that going and directly working on the XML gives you more flexibility and more visibility on what goes on in the back end. So the flows form every Mule application is going to have flows, and everything is going to reside within flows. There is nothing that is outside of flow. All the applications that we are going to create, the basic unit within the XML that we are going to create is the flow, and we are going to have 0 to 1 message sources and 1 or more message processor. So every flow is going to typically start with a message source, and it's going to have more than one message processor at least. And some of the message processor: transformers, routers, filters, and components. Transformers, as we know, it is going to transform the data from one format to other. Routers, as we know, if there are multiple target systems that message should go or be routed to, then we use some of the routers that are available. And filters are for if we have a logic that if we are expecting some data to come, and then the next say the next application, the next processor in the chain, if it expects only certain data to flow to it, and all the other so basically, let's say there are data 1, 2, 3 that is flowing, and if the next processor is only interested in data 3, then we need to filter out data 1 and 2. So to get that logic written, we use these filters. And components is more customizable and an extensible feature, wherein it provides more like flexibility to the developer to write his own business logic. So we would be able to configure a component and write all the Java logic that we want to write for that particular message processor, what it needs to do. It can be a specific data transformation that we are doing. It can be more data manipulation before we take a decision to the next, before we get the message ready for the next processor. So it can be anything. It's basically a placeholder if you want to write any business logic specific to our domain, which is not covered by Mule ESB itself. If there are no particular out of the box feature that the Mule provides, then we would be able to use these components. Let's go and we'll just go to the application itself and see how to develop it. So I've downloaded the Anypoint Studio. I have already installed the Anypoint Studio, the Mule IDE that it gives us for creating these applications. It's Eclipse based, normal. Okay. Let's create an Hello World application. Okay, so this section is the canvas section, wherein we would be able to drag and drop all the components that Mule provides us. So these are all the components that we have, like these are all the drag and drop elements that we have that Mule provides us. This is the palette section from where you can drag and drop things onto the canvas, and at the bottom you have the properties window. So this will act as a properties window. As you drag and drop the components, you would be able to configure each one of them here. And this is the configuration XML that we have. So whichever component you drag and drop, at the back it writes an XML element for that particular thing, and all the configurations that you do either become as a property of it, attribute, or a separate element in itself. So all those things will be written automatically for you, and we can take a look at how the code looks. But at last, it's the XML that is going to be used during the deployment and during the execution stage. So that's one thing. And so this hello world.xml, this is the main file, So this is called as Mule Config .xml. So this is the configuration file which is going to have you can say this is the usually when they say what's a Mule configuration file, then they mean this file, hello world.xml. So this takes the application name. It takes the application name. This is the file that is going to orchestrate everything within the Mule application, and you have normal Maven folder structure, and you can create a lib folder if you want to integrate third party any other API that you want to integrate into your application. You can create a library folder and then use it. So that's about it. Now let's go ahead and create an hello world thing. So first let's go to the connectors. Connectors are the ones. So I'll introduce you to on a high level what these means. Connectors are the one which are going to act as your message sources, the starting point of the flow. So you have HTTP connector, file connectors, FTP, database. So there are various connectors that are available which can be used as the endpoint for an application. So if you are having two applications that needs to talk to each other, and the way we are connecting these applications are using the connectors. Basically these connectors are an abstraction of the underlying protocol, the underlying data format that it works with, and the underlying application that it connects to. So it's basically an abstraction that Mule provides, and it's a reusable stuff as well. You can, if you want to connect to a queue, open source message broker which follows the JMS standards, and it would be you'd be able to drag and drop JMS connector there and configure it within the application. So you have various connectors for all different sorts of protocols that may be available in the system and in the market. And VM is one important thing. Whenever you want to do some kind of testing and then you don't want to integrate it with any actual application that connects, you don't want any actual physical application or a system to connect to, but you just want to test how the data flows. If you want to use this both as a message source or as a message receiver at the endpoint, the outbound endpoint, so you can use VM, which is nothing but, it stands for virtual machine. It's nothing physical, it's fully logical, but we would be able to send and receive messages through this VM. If you're developing an application and if you still don't have the application that it is that this process is going to interact with, but you need to develop it and test it, then you can go for VM. Later on, when the actual application is available and you have all the configuration details, then you would be able to replace that particular connector. You can have that particular connector replace the VM one. But otherwise, you have all the other things that are available. You can configure and then just use it. So for this example, we'll go with the HTTP, the more commonly used one. So as soon as I drag and drop this connector, HTTP connector, there are few things that we need to notice here. So it is embedded within a flow. So it says hello world flow. That means we have got a flow element created here. So that's what I was talking about. It is in any connector that you drag and drop, you would have a flow created, and then that connector would be the first line within that flow. So herein we just dragged and dropped an HTTP connector which is embedded into a flow. So we are so that's what it does. Everything is a flow, nothing resides outside of the flow. So as you drag and drop, a flow got automatically created, and this became your first element, and this is going to act as your message source. That's why this particular line which separates the processors from the message source. And this double arrow mark, both directions, it means that its response flow is also there, meaning it's not one way, it's going to be a synchronous response flow. Always there is going to be a response that is returned. So in Mule, the latest version that they have released, the 3.61, they have made sure that this response flow is very intrinsic and it's implicit as well. We don't have to do anything. By default, it's the response flow is going to be there and we are going to receive something. Even for we should not confuse this with synchronous and asynchronous one. In the synchronous, yeah, this is going to be straightforward. It's going to have some processes and it's going to receive some response. In that way, we are good. In an asynchronous process, wherein when a particular flow supports asynchronous process, at that time the response part of the application, what is it going to do is it's not going to return any message to the response flow. It is only going to return the status, whether the whether the message was delivered to the target application successfully, or at least whatever was configured in the message processor, everything was executed successfully. It's just going to return a success or a error status. That's it. This is different from the fire and forget. Like in Ajax calls, when we used to fire and then forget and then later on have a callback mechanism done, which is going to handle the response that is going to come. That's entirely different from the asynchronous here that we are talking about, because here in this asynchronous flow, we are not expecting any response to flow here. It's going to be only the status in the case of asynchronous that is going to be returned to the actual starting point. In the case of synchronous, yes, it's going to finish off all the processes that we are going to configure, and at last it's going to return the message that's present at the last processor in the sequence of elements that we have configured. That's what is going to return. Now we'll see what is that is going to get returned here. Now we have got this HTTP thing configured. Let's configure the listener for it. Let's go to the properties tab. So we need to configure a listener here, meaning which IP port and all it's going to listen to. By default, let's leave it to all ports that is going to connect. It can take it from anything. It can take it from localhost. It can take it from any IP that it's going to connect to. And the port that it is going to listen to is 8081. And it's the HTTP protocol is the default one. So let's have all the defaults as such. Don't have to do anything. So as soon as you got it created, you are able to see it here. If you want to edit it, just click on this button. You would be able to see this. So the thing that got written is this one. So we created a new listener, and that listener is created here. So this is outside the flow, meaning this is going to be a reusable component. This listener can be used by multiple endpoints within any number of flows. You can have another flow here, and then if you have an HTTP listener, then you can use this listener config to get all the properties of what is the host, what is the port number, and all that. So this way you are able to reuse it and not each and every time code it. So if you have it's a complex application and you have multiple flows defined and many are going to use this particular host and port, then it's better to have it in a separate listener and just configure that listener's reference here by using the config-ref attribute of HTTP listener thing. So this endpoint is going to use this reference attribute to have it. So if there is a change, if there are 10 flows that are using 10 flows and 10 HTTP listeners which are using this particular configuration, then it's better to have it in one place centralized and change it in one place so that the change gets affected in all the other places. So this is the same how other most of the other connectors that are available also works. The configuration itself will be separate, and it would just be referenced within the actual endpoint. So this is so the word inbound endpoint will be mostly used. Inbound endpoint is nothing but the starting point, which is the starting point of the flow, and where the message, and which acts as the message source. So this is going to act as the message source now. So this can be either called as inbound endpoint, and more specifically it's an HTTP endpoint because it's the transport layer behind the endpoint is HTTP. And we have this created now, and now let's go and see let's add a payload to it. Payload is nothing but the actual data, the actual content, that actual message that flows through the application. So let's try, as of now we are not going to receive any payload in this application. We are just going to hit this endpoint without sending any message to this particular endpoint, but we are going to create a payload and then set it and then send it back to the source itself. So this search window is helpful in searching the various things. So set payload is the one that I'm searching for. So that's a transformer. I'm going to drag and drop it here, and so this is a kind of transformer, and herein this transformer is used to set the message payload. So if there are so this can be, herein we are just using it to set the initial payload for the application, but its usage is more when you have something in a big flow. You want to change the depending upon a particular scenario wherein a flow changes, you want to send a particular data to that particular message processor. So you want to form a new message payload instead of the one that is flowing through the application as of now. So in that cases, or you want to manipulate something, or you want to add something to the message. So this message enrichment concept is one of the main concept in ESBs, wherein you have a message flowing and there are some parts of the message that didn't come through, or you want to enrich the message by putting more attributes, more information to that particular message for the next processor to take it and use it. So in those cases, the message enrichment can be done via this set payload thing, wherein you are able to set the actual payload that the next processor should use. So you can we can change the name of the payload, set hello world message, and herein we are just setting hello world. So we are setting hello world, welcome to Mule. This is the message that we are setting, and we can save it here. Okay, let's go back and see what it has written here. So there is a set payload element, value equal to hello world, welcome to Mule, and doc name. This is the actual display name of that particular element in the visual UI. Nothing to do with the actual logic itself. So we have created here. So when we were talking about that response that goes through the that goes in the application, it's the same thing. So when we would be hitting this particular endpoint through a browser, we will be invoking an URL, and when the URL is invoked, this is a message source. So there is only one processor that is present in this particular flow, and that processor is nothing but a transformer specifically, and this transformer is a set payload transformer, wherein it sets the actual message payload that's going to flow through the this application. So the payload that we set is a string thing. We set hello world, welcome to Mule, and that's it. So there is no other message processor that we have connected to it. So this flow is in. So this flow is called request flow. The initial flow till the last message processor is called the request flow, and after that whatever the 0 mark comes back to the source, this is the response phase. In this response phase, it's going to return the message that's going to be that was there at this point. Whatever the last message processor gave us an output, that's going to be the message, that is exactly the message that's going to be written to the starting point as well. So we'll see, so when we return it, what we are expecting is that we hit this URL from a browser, and it goes and hits the next message processor, which sets the message payload, which is returned back to the browser, and it will be displayed in the browser. That's where the response is used. We will get the actual response that is displayed on the browser itself. But if you look at the XML itself, you will not see this particular response flow explicitly written anywhere to say that yeah, there is going to be a response that is going to be returned to the starting message source. It's not there, but the reason it is assumed that it is implicit, and we understand that. So in all the flows, the response flow is the response phase of the particular flow is very implicit, and it's going to happen regardless of whether it's displayed or not. So to execute this application, just right click this Mule Anypoint Studio, the Mule IDE. This has got the Mule server inbuilt. So when we created this application, we had the Mule 3.6 server runtime already present there. This one, the Mule server 3.60 so it's already there, so we can just go directly run as Mule application. Okay, so when you see this deployed message, and this is the application name, and we have got it deployed. So when this is displayed, you can understand that the application is started and it's deployed. Otherwise, it will be failed here if there are any issues. And here you can see that the HTTP listener that we have configured is listening onto this particular IP and port. And there is one flow that is there in the application, that's the hello world flow, and that flow has been started. So these are some of the things that we can see in the logs. And now let's go and see how this can be executed. Let's open a browser. Let's say localhost 8081. So when we hit this localhost 8081, wherein this server is actually listening to, then our Mule Flow starts. Our Mule Flow, it was listening to this 8081, and the localhost is it was listening to any IP that it comes through, and the path was nothing. So when I hit 8081, I am directly hitting this particular endpoint. So as soon as I hit this endpoint, this flow, this message source gets so Mule is more of an event-driven based ESB. So there is some event that needs to kickstart the whole process going. So the event here is invoking of this particular URL, and how this event is invoked, because we have a listener configured that listens to this particular IP and port. So through this listener, we are able to send an event and invoke this flow or start this flow. And once the flow is started, we are able to hit the next message processor. Here in this case, it's a transformer, and more specifically, it's a set payload transformer, wherein we set the payload. And if you see, that's why we were able to receive the response back here saying, hello world, welcome to Mule. And if you see the console, you will see that available listeners are star. So we have not got, if there is a payload that was sent here, then we would have got that payload also printed. Since we have sent no payload and just an empty, we just hit the listener, the starting point, the message source directly, and after that the message payload was set within the application itself, and we were able to get that as part of the response, which is an implicit nature of using Mule. So So this is how this is the basic Hello World application, wherein you have configured a particular endpoint, the inbound endpoint, which is an HTTP endpoint, and within a flow, and we are able to use one particular message processor and orchestrate it. So this is the most simplest of application that we can develop.